Right, so once again, good morning. So
Morning,
can
sir.
you guys see my screen now?
Yes, sir.
All right, so do you guys have any question or concerns regarding with our last module?
Yan naman po, sir.
Right, so if there's no questions, then let's now start with our module 4. So as you can see, our topic for today is relation. So to those who are already done with Math 100, so this is actually like a deeper or another topics when it comes to relations. Okay, so most of the topics in here are already part of the Math 100. So this one is already super easy to understand for you. Okay, so first, what is the meaning of relation? So as you can see, we will only be able to build a relations once we have two sets. Okay, so we cannot have a relation if there is only one. Okay, so that is why we call that one relation. So if you're to take a look on this one, we have two sets. Let's say set of x and then set y. So to have or to build a relation, so let's say one factor is to make or to have a Cartesian product, okay, via combining those two, okay. So to get all of the possible relations, we will use Cartesian product, wherein you'll just simply multiply all of the elements of your x and then all of the elements of your y. Okay. So in Cartesian product, this x is mostly called the domain. Okay. So take note on that one. And then for the y, we call this one range. Or sometimes we call this one codomain. Okay. So domain for the x and then range for the y or codomain. So it's the set of all ordered pairs x, y. Okay. So you guys already know what is Cartesian product. It's just simply multiplying the first coordinates to the second coordinates. Okay. So whatever is your first coordinate, that is your domain, and then whatever is your second coordinate, that will be your range. Okay. So as you can see in Cartesian product, arrangement matters. Okay. So here's your first coordinate. Here's your second coordinate. Okay. And then whatever is the elements of your x, that is your first, and then whatever is the elements of your y, that is the second coordinate. Okay. So x is an element of set x, and then y is an element of set y. So in symbols, you can write this one in this kind of manner. Okay. So it is in a set such that element xy is an element of x and elements of set y. Okay. Same with this one. So the first element x of the ordered pair is related to the second element y of the ordered pair. So we call this one binary relation. Okay. So each set, okay, having a first coordinate and second coordinate, we call that one binary relation. So from the word binary, we have two coordinates or we have two elements on that relation. Okay. All right. So what is this binary relation? So it is a relation R from a set X to a set Y is a subset of the Cartesian product X times Y if element XY is an element of R. Okay. So you can denote this one as X R Y. Okay. So this X R Y is just the same with this XY is an element of R. So in here, we're just saying that this XY is in relation or an element of relation. Okay. So the same with this one, meaning x is related to y. Okay, or x is in relation with y. Okay, meaning we have a certain relation. Okay, but of course, before we could say that they are in relation, so we should take a look on what are the requirements to check before you can see that they are in relation. Like for example, they are related by blood, they are related by friends only, they are related as a co-worker. So we have a lot of kind of relations like lover, enemies, and so on and so forth. Okay, so that's one thing that you need to check before you can say that they are in relation with each other. Okay, so in here we have the student and then the course. So Bill is actually related with Comsci, meaning maybe uh, the course of Bill is Comsci. That is what he is taking right now. Okay. And then Mary is related with math, maybe because this is his course that he is taking right now. And then the same with this one. Bill is another, or again, related with art. So you could say that Bill has two courses that he is taking uh, consecutively. Okay, so he's taking comp sci, and at the same time he's taking art. Okay, and then Beth is taking history and then taking comp sci at the same time. Okay, and Dave is related with math. So that's the relation. Okay, so you could say that each one of them has one course or two course. Okay, so that's their relation. So let's have another more example when it comes to relation for you to understand this one. So with the table, we can derive relation as Bill is related with ComSci. So basically, we just put it inside a set wherein each call this one, each binary relation, okay, contains two coordinates or two elements. Okay, so of course, the first one is the x or the domain, and then the second one is the range. Okay, so this one came from our table. Okay, so Bill comes I, Mary Matt, Bill Art, and so on and so forth. So this one now is in a form of a set, okay, or set relation. Okay, thus we could say that uh, bet history is in relation with R, or bet R history, or again bet R is in related with history. Okay, so where this one came from, it came from this part. So at the same time, you can say that Bill is related with ComSci or Bill R ComSci, and so on and so forth. So you can do that on all of those examples. Okay, or binary relation. So are we clear so far on how did we come up with this kind of relation set or set relation?
Yes, sir.
Yes, sir.
Okay,
Yes,
all
sir.
right. So this one is actually self-explanatory already. Anyway, so this is like a bonus already. So you're going to have a seat break, which is very similar with this one. So we have four tables wherein you need to come up with an ordered pair, okay, or binary relation, just like this. Okay. And then we have the number five, which is the opposite of this one. So you have to come up with a table. So from binary relation into a table. Okay. So are we good so far for the secret number one?
Yes, sir.
Yes, sir.
All right. So let's now move on to the harder topic, which is relation using graph. Actually, this one is not harder. Uh, Still easy. Okay. So we have two sets in here, let x and then let y. So x contains an element of 1, 2, 3, and then y contains an element of a, b, c, d. So you can define this one using a Cartesian product. No. Sorry. This one not came from a Cartesian product. Okay, so this is just a random relation that came from those two sets. Okay, so we have here 1a, 1b, 2a, 2b, and then 2c. Okay, if you're going to get the relation using Cartesian product, you will have or you'll arrive at 12 total of relations. But in here we only have 1, 2, 3, 4, 5. Okay, so those are just random, okay, relation that came from our sets. Okay, so in here we just want to show that this relation can be shown using a graph or this one. Okay, so we have this y coordinates and then x coordinates. As you can see, the x coordinates is our domain, which is the first one, which is 1, 2, 3, and then the y coordinates is our range, which is this one, a, b, c, d, which is labeled as you can see on our presentation. Okay, so what we want to do here is to plot, okay, each relation on our graph. So as you can see, we have 1a, then we have to plot it in here. So we have 1a, 1b, 2a, 2b, and then 2c. And all of those are in relation or a set of relation. Okay, so this one is an example by showing this set relation into a graph. All right, so let's talk about the main range of relation. So as I mentioned a while ago, all of the elements under X or your X axis, which is this one, okay? The horizontal line is your domain, and then all of the elements of your y or your range is your y or range of your y is your range, okay? Which is this one, okay? So all of the elements of x is your domain, and then all of the elements of y is your range, okay? So as against right here, we have the domain and then the range. So this one came from, is it the same with this one? No, this one came from nothing, okay? This is just an example, okay? This one is just an example of a domain and then range, okay? So this one is our x, and then this one is our y. All right, so let's have another example. So using the table before. So from here, we could already see that the domains are Bill, Mary, Bill, Beth, Dave, okay? And then the range is comp sci math, art, history, comp sci math. But then again, since it's in a form of set, okay, so it should be only distinct and of course no repeated values or element, okay? So as you can see, we have two bills and then we have two bed, okay? But since it's in the form of a set, then we have to remove the repeated element, okay? So in here, we could say that the domain are Bill, Mary, Beth, and Dave only. And then for the range, we also have 4 because comp sci is repeated, and then math is also repeated. So you have to remove the repeated elements. So we have only come up with 4 range and then 4 domains. Okay. So are we clear so far up to this point?
Yes, sir.
Yes, sir.
Right. So again, if you guys have a question, so feel free to ask me anytime. Okay. Okay, so let's have another example. So we have set x and then set y. So set x containing 2, 3, 4 elements, and then set y contains 3, 4, 5, 6, 7 elements. So we have here a question, and then its condition. Okay, so define a relation R from x to y. So this is one very important keywords that you need to take a look or check every time. So we have here from x to y. So take note from x to y. Okay, so x first before y. So if this one is from y to x, then you should start with y followed by x. Okay, that is your first condition to form a relation. Okay, so that's we can say that x, y is an element of R if x divides y, having 0 remainder. So in here we have another condition wherein for us to be able to build a relation or a binary relation, we should follow or we should come up wherein x divides y having a 0 remainder. Okay, so as you can see, there's no solution in here. Okay, so I would like you guys to analyze this one, okay, on how to come up with a certain relation using this condition. Okay, x divides y. So my only question is this x divided by y or y divided by x? Anyone from the class? Is this x divided by y or y divided by x?
I think x divided by y.
Mm-hmm.
X divided by y.
X divided by y. How
That's
about
what
the
I
Sir,
think.
y
others?
divided by x. Sir, y divided by x.
Y divided by x. So the correct answer is y divided by x. Okay. So don't get confused on this one. X divides y, meaning your x is going to divide the y. Okay. So meaning your x is the divisor. Okay. So don't get confused on this one. It doesn't mean that it's x divided by y. Okay. All right. So let's answer this one. So let's see what are the possible relations that we can come up using this condition. All right, so again, we have here y divided by x. okay, and then it should have a remainder of 0. Okay, really say even. Okay. Okay, because if it's even, then we don't have a remainder. Okay, so y divided by x, so 3 divided by 2. Okay, so are we going to have a remainder if it's 3 divided by 2?
Yes, sir, meron po.
There is. So 3 divided by 2 is not included in our relation anymore. How about 3 divided by 3?
Pwede, sir.
So since we have, or we don't have a remainder in that one, and we have an even result, which is 1, so we can list that one as our first relation. So how about 3 divided by 4?
Di pwede, sir.
So no, so we will not list that one. So 4 divided by 2?
Pwede, sir.
Possible. Okay, so we have to list here these coordinates. How about 4 divided by 3?
Di pwede, sir.
No. How about 4 divided by 4?
Pwede, sir.
Okay. So as you can see, all we need to do is follow this condition, okay? Up to the last key. It's like distributing everything from this side to that side, and then this side to that side, okay? So FOIL method. So 3, 2, 3, 3, 3, 4, 4, 2, 4, 3, 4, 4, 5, 2,
Excuse me,
5.
sir.
Yes?
Are we writing y for x before x or x before y?
Y first, Y. Okay, Y divided by, sorry. X first before the Y, okay? So my mistake. Okay, this one should be 3, 3, 2, 4. 2, 4. So thank you for that one, Mr. Walawewa. And 4, 4. Yeah. Okay. So X first, followed by the Y. Okay. But when it comes to the second condition, we have to follow this format. Okay. Y divided by X. Okay. So how about 5 divided by 2, 5 divided by 3, and then 5 divided by 4? Is there an element or coordinates that wherein it's equal to even or having a remainder of 0?
None, sir.
None, right? How about 6? What are those elements?
3 and 6, sir.
2 and 3.
2,
2 and
6, 3,
6.
6.
And then 3 and 6. Okay.
Yeah.
How about 7?
None.
None.
None, right? Okay. All of them will give you a remainder. Okay. So as you can see right here, we form 1, 2, 3, 4, 5 relations. Okay. So yeah, this is now our answer. Okay. So are we clear so far when it comes to forming a relation or set relation?
Yes, sir.
Yes, sir.
All right. So again, the first thing that you need to look at is this arrangement of your coordinates. So x first, followed by the y, and then whatever is the second condition, wherein we have here y divided by x having a 0 remainder. All right. So let's now move on to the example number 3. So we have here set x, where it has an element of 1, 2, 3, 4, and then addition are defined by xy. Okay. So if x is less than or equal to y, and xy is an element of x. Okay. So as you can see right here, we only have one set, but we have a condition here that our here we have a condition here wherein our x coordinate and then y coordinate will be coming from our x or set x. Okay. So those two are an element under set x. Okay, so it could be 1, 1, 1, 2, 1, 3, 1, 4, and so on and so forth. Okay, so what is our next condition is 1. So x should be less than or equal to y. Okay, So actually you can use Cartesian product in here, okay, since all of your coordinates will be coming from one set. So let me just copy this one. And then paste it right here. So we have this condition, x should be less than or equal to y. Okay, so let's write those relations. Okay, so from here we could say 1, 1,
1,
2,
1, 2.
1, 1, 2.
No, 1, 2, 1, 3,
Mhm,
1, 4,
mhm. What else?
2, 2, 2,
2, 2,
2,
and
3,
2, 3.
2, 4,
Okay, and then
3, 3,
3. Okay, very good. And
3, 4, 3, 4,
what else?
4, 4.
4, 4.
All right. So as you can see, super easy when it comes to forming a relation. As long as you know on how to solve or analyze this rules or condition, then you're good to go. Okay. So in here we have a total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of binary relations. Okay. All right. So let's move on to the next example. So in here, draw the relation or using the diagram. Okay. So first, when we see diagram, okay, this one is a connection or a relation between two elements. Okay. So from this to this point. Okay. So let me show on how to answer this one or draw those relations using a diagram. So this one is super easy. So as you can see right here, we have a relation 1, 1, blah, 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 and so on and so forth. So this one is actually the answer from past example, the one that we just answered. So if we have 1, 1, then you can answer this one as this one. So as you can see, we have 1, 2, 3, 4 elements. So we have 1, 1, oops, 1, 1. Okay. So 1 will just go back to itself. Okay. And then we have 1, 2. Okay, so 1 going to 2, oops, yeah, and then 1 going to 3, and then 1 going to 4, then 2, 2. So again, it will just go back to itself, and then 2, 3, and then 2, 4. Then we have here 3, 3, and then we have here 3, 4. Oops. Then we have 4, 4. Okay. So this is now the representation of this set relation into a digraph or diagram. Okay. So did you get it so far?
Yes, sir.
Yes, sir.
All right. So this one is super easy to follow. Just know the coordinates of those. All right. So let's have another example. So draw the relation R on X having an element of A, B, C, D defined by R, AA, BC, CB, DB. Okay. So it says here draw. So we should come up with a diagram or diagram. Okay. Let me just copy this one. All right. So from here we have elements A, B, C, and D. So oops. So we have A, B, C, and then D. And then we have this relations. We have AA. Then we have BC. Then we have CB. Then we have DB. Okay. So this is now the diagram representation of this relation. All right. So very simple. All right. So once you're done in understanding everything, all of those from page 1, slide 1 to slide 12, then you may now start in answering this Seatwork number 2. Okay, so we have letter A, letter B, and then letter C. So for letter A, draw the diagram of the relation. So just the same in this one or similar. Okay, and then for letter B, write the relation as a set of ordered pairs. Okay, so you should come up the same with letter A as a result. Okay, given with this diagram. And then letter C, the relation R on the set 1, 2, 3, 4, 5 defined by the rule x, y is an element of R. And then we have three conditions. Okay,
Sir,
so yes,
the letter B of B has no relations. How do we write that as other pairs? BB.
this one.
Yes.
So since there is no, this one should be your assignment. Okay, so as I can see, there is no relation. Okay, so I'll just give this one as a bonus. Then just list that as no element or an empty set. Okay, since there is no relation. Okay. So did you get this one now?
Yes, sir. Thank you.
All right. Okay, so again, for the seat work number 1 up to the end of the seat work of this module, so you can do it handwritten or you can do it via Microsoft Word. Okay, so please, if you're going to do it handwritten, please write legibly. Okay, and then from here, you have additional tasks to do. So you have to identify the elements of R of this letter A, then the domain of R, and then the range of R. Okay, so do not just get the ordered pairs. Okay, so get the elements and then the domain and then the range. So the same with B and letters. Okay,
Either.
all right. So let's now move on to the next one. So we have here properties of relations. So we have here reflexive, symmetric, transitive, and then anti-symmetric. Okay. So for reflexive, so as you can see, it reflects itself. So if we have one element, then it should also reflect itself or its own element. So let's say we have 1, 2, 3 elements. So the only time that you can say that it's reflexive if we have 1, 1, 2, 2, and then 3, 3 ordered pairs. Okay, so this one is super simple, reflexive. Then we have here symmetric. So you can say that it's symmetric if for all x, y is an element of x such that x, y is an element of R, then yx is also an element of R. Meaning, if we have this kind of ordered pairs, let's say 1, 2, then you should also have 2, 1. All right. So if you have, let's say 2, 3, you should also have 3, 2. Okay. So they are now symmetrical. Okay. So it's like mirrored. Okay. So this one is also super simple. And then transitive. So this one is also super simple, which came from hypothetical syllogism. You can still recall this one on the induction. So we have here x, y as an element of R, and then y, z as an element of R. And then imply x, z is an element of R. Meaning, once you have find out that you have this kind of ordered pair, we have x, y, and then y, z, wherein they have the same element for this one, y, and then y in here, then you can come up with an x, z, or another ordered pair. So once you saw this one, x, z, okay, in this ordered pair, then you can see that they are transitive. But if there is one element that doesn't have this x, z, then that is not transitive anymore. Okay. Anyway, so we're going to have more examples for this one later on so that you guys will understand this one more. Okay. And then we have this anti-symmetric. So as you can see, this one is completely the opposite of symmetric. So if this one is not symmetric anymore, okay, let's say we have x, y, but we don't have yx, okay, then that one is already antisymmetric. Okay, so as simple as that. All right, so let's start with the reflexive relation. So as I mentioned a while ago, if we have this elements 1, 2, 3, 4, then you should have 1, 1, 2, 2, 3, 3, and then 4, 4. Okay, you can just disregard the others. As long as you have those, then you can say that this relation is reflexive. Okay, so yeah, the question is a relation reflexive. So relation R is reflexive because each element X is an element of X, XX is an element of R. So specifically the 1, 1, 2, 2, 3, 3, and then 4, 4. So did you guys get this one so far?
Yes, sir.
Yes, sir.
Okay, so this one's very straightforward. If it's reflexive, it should reflect its own element. Okay. All right, so we have here another example. So let R AA, BC, CB, and then DB. So is this relation reflexive?
Yes, sir.
Yes, sir.
Huh?
Yes, sir.
What are the elements on our relation?
AADD.
AADD.
AABB only?
ABCD.
ABCD. That's it. So take note, we have here an elements of A, B, C, and then D. Okay. And then for you to be able to see that this one is reflexive, if we have AA, BB, CC, and then DD, right? Is this
Yes.
correct?
Yes, sir. Yes, sir.
This, for us to say that this one is reflexive. But how about this example? Is this reflexive or no?
Sir, oh, I actually thought we can actually just, so far some of the elements are reflexive, because that's what I thought. That's what I said. Is
No. Okay. So when we say reflexive, all of the elements should reflect itself. Okay. It's not
okay.
suffice that there is only one element that reflects itself. Okay. So yes, it is true that for some it is reflexive, but for all it is not reflexive. Okay, wherein the condition of reflexive is it should be all. Okay, everything. Okay, as you can see right here, we have 1, 2, 3, 4. 1, 1 has its own reflection to itself. 2, 2 has its own. 3, 3 has its own, and then 4, 4 has its own also. But in here, we don't have the BB and then the CC. Okay, so that is why this relation is not totally reflexive or not reflexive at all. All right.
Okay, sir. Okay.
So I hope this one is clear. When we say reflexive, all of the elements should reflect itself. All right, so since we don't have enough time anymore, so we will just continue the remaining slides on the part 2. Okay, so I will end this meeting now, and then I will create a new link or a new room again, and then just join right away. So right now we have 17, or we are 17 participants, so I'm expecting the same participants also. All right. So before we end, do you guys have a question?
Wala naman po, sir.
Oh, sir.
All right. So let just wait for the second link. Goodbye.